So the second largest biomolecules is nothing but the proteins. Now, yesterday itself, I told you a little bit information I gave you about the proteins. Okay, so I'm just going to brush up that fast and I'm going to continue. Okay, so proteins, as I told you, they are nothing but the biomolecules which are made up of nitrogenous organic compound. Means how are these proteins formed? By the condensation, polymerization of amino acids. Okay, so there is a basic structure of an amino acid, which is important if you need to draw the other, like as I told you yesterday itself, there are 20 amino acids, right? So if we know this basic structure, just we have to replace the R group by that particular functional group, and then it will be a particular type of amino acid. So that structure I'll just draw over here. Okay, so this is the basic structure. Basic structure of amino acid. Okay, so now these things which are there. So here the first one, NH2, it is nothing but the amine group. COOH is the carboxy group. And R is nothing but the side chain. Okay, now usually whatever proteins are there, they will be derived from the alpha amino acids. Okay, so therefore all the naturally occurring amino acids will be the form of what? Alpha amino acids. So hence, if they ask you that what is this alpha in that particular structure, it is nothing but whatever proteins are there, they are mostly derived from alpha amino carboxylic acid monomers. Okay, so what is this alpha amino acid? Alpha amino acid means an amino acid in which NH2 group, that is amino group, is present at the carbon atom adjacent to carboxyl group. Okay, so therefore, whichever amino acids will be there, they will exhibit a phenomenon called as stereoisomerism. What is stereoisomerism? Yesterday itself, I taught you the two types, that is D and L. Okay, so because these alpha amino acid exhibits the stereoisomerism, means the dextro and levo rotatory as well as isomerism they can show. So whatever naturally occurring amino acids are there, all those are most probably the L1. Okay, so L is nothing but most of the naturally occurring amino acids are in a stereoisomerism form of L. Okay, so depending upon this only, that is the NH2 group and the COOH group. Now, obviously, whenever there is a polypeptide chain to be formed, there should be some kind of proton loss and taken, right? So those thing is called as what? Well, there is one term, very important term, okay, which is called as Whatzwitterion. Okay, this is a very important term, Whatzwitterion. Now, what is this Whatzwitterion? Whatzwitterion is nothing but it's an ion wherein there's a transfer of proton from carboxy group to amino group. Now, what does this mean? That is transfer of proton from carboxy group to amino group. Means whenever a COOH group lose a proton and the amine group accepts it, then what will happen? Losing a proton and accepting by the same kind of group which is present in that atom, then what will happen is it will have or it will become a dipolar ion. Means both the charges will be present, positive and negative. So hence it is termed as what? Neutral. Okay, so Whatzwitterion is nothing but it's an ion wherein the carboxyl group will lose the proton and that proton is been accepted by the amine group. So when it does so, that particular ion becomes neutral, means it will be having both positive plus the negative charges. And these kind of ion is only called as what? Whatzwitterion. I'll just draw it in a structure form. Okay, so suppose there is two electrons, sorry, the proton, then okay, so you can see that after the conversion, means after acceptance of the proton, what is happening? A negative sign as well as a positive sign is present over here. Means both the signs are there. Therefore, they become what? Neutral and hence termed as a Whatzwitterion. Now, because both the charges are present on them, the Whatzwitterion, they form an amino acid which is having what? Amphoteric nature. Amphoteric nature. Ampho means two. Okay, so because they are having an amphoteric nature, positive, negative signs are there, so they can react with both acids and base. Okay, now this is applicable to all the amino acids, that is all the 20 amino acids except one, which is glycine. Okay, exception. Except what? Glycine. So if you leave this glycine, rest all the amino acids, they are what? Having this particular nature and all are optically active. And yesterday itself, I told you what is optically active means what? They will be having the alpha carbon, which is asymmetric. And asymmetric meaning what? 4 different groups are attached to the carbon atom. It's called as asymmetric. Okay. So this is a very important point. That is, what do you mean by a Whatzwitterion? Now, depending upon the charges and the neutrality or the amphoteric nature, there is one more term associated with the proteins called as isoelectric point. Now, isoelectric point is related to the pH. Okay, means what is this term actually? It is nothing but the pH at which dipolar ion exists as neutral ion. Now, what do you mean by dipolar ion exists as neutral ion? It means positive and the negative charge, it becomes equal. So when the positive and negative charge becomes equal, there will be no sort of migration. No migration to any of the electrodes under electric field. This is called as what? Isoelectric point. Means there comes a point, okay, wherein whatever dipolar ions are there, it will exist as a neutral ion. Means there will be no migration of either positive charges nor negative charges to any of the electrode, that is anode and cathode. Hence, one of the speciality of these kind of isoelectric means this term isoelectric point is what? Those kind of amino acids will be having the least solubility in water. Okay, so because of the isoelectric point, what happens? These amino acids, they will be having least solubility in water at an isoelectric point. So because they have a least what do you say, solubility in water at their isoelectric point, it will help in what? Separation. So if you want to separate the amino acids from one another, you can use this point, that is isoelectric point, because of its least solubility. And when that particular ion reaches the neutral thing, wherein there is no taking in or giving out the charges, then that time what will happen is you can easily separate two or more amino acids. So basically what happens in this is, like as I told you, two types of mediums are be there. That is, one is the acidic medium and other one is the alkaline medium, right? Because the Whatzwitterion, I told you earlier, it is having an amphithetic nature. Correct? Amphithetic nature means what? These ions are capable of reacting with both the acids as well as bases. So now what happens in an acidic medium and what happens in a alkaline medium, that we are going to see. Okay, so if I take the acidic medium, okay, in the acidic medium, what happens is whatever the COOH ionic group is there, it will act as a base. And it will accept whatever proton is there. Okay, so because this particular carboxyl group, it will act as a base and it will accept that particular proton. Whatever your amino acids will be there, is the alpha amino acid, it will exist in the form of cation. Okay, this happens when it is acidic medium. So the opposite will take place when it is an alkaline medium. Opposite. Okay, that is, here if it is carboxylic, here what will happen? NH3. This will act as acid. So because it is acting as acid, what it will do? Obviously, it will lose the proton. So because it is losing proton, the alpha amino acid will exist in the form of an anion. Okay, so this is what happens when you apply some electric field and when there is a migration towards the anode or the cathode respectively. So when this particular things are taking place, okay, that is at an isoelectric point, at that time what happens is, at some intermediate value of pH, whatever concentration of cationic and the anionic form becomes equal. So again, what will happen? Cationic anionic forms becoming equals means there is no migration. And if there is no migration, you get something which is called as isoelectric point. Okay, so to make it simplifier, I'll just draw the structure. It'll be easy for you. Okay, I'll take the basic this one formula. Okay, so this will be like R H C. Okay, so the first one which I am drawing is in an alkaline solution. Okay, same what I'll get in a acidic solution. Instead of OH minus, H plus. Okay, so whatever I have written here in this page, I have just converted into the structural form. Fine. So next one is what? The types of amino acid as well as the structure of proteins. Okay, so types of amino acids, it's quite easy. Okay, but still one more time, I'll just write it down over here. Types of amino acid. Okay, so the amino acid has been classified depending upon two things. One is the depending upon number of amino and carboxyl group, and second one is on the basis of synthesis. Okay, so depending upon the number of amino as well as carboxyl group means what? Again, there are three types in it. First one is the neutral, second is acidic, and third is basic. So neutral means nothing but both these groups, that is NH2 and COOH, they will be equal. In acidic, what will happen is the COOH will be greater than NH2. Whereas in the basic, it will be the opposite. Okay, that is NH2 will be greater than COOH. Okay, so these are the three classifications depending upon what, how much, like what is the number of NH2 and the carboxyl group, whether it's equal, greater or lesser on that basis. And the second one is on the basis of synthesis. So synthesis, again, two types are there. One is the essential and second one is the non-essential. So essential means what? Can't be synthesized. By our body, hence it should be taken up via the diet. Whereas non-essential means what? It can be synthesized. by our body, hence need not to be taken externally, okay, in by the diet. So as I told you, there are 20 different amino acids, right? So out of this 20 amino acids, 9 amino acids are said to be the essential, and rest of the 11 are what? Non-essential amino acids. Okay, so this is all about the types of amino acid. Next is very important thing, that is structure of protein. Now, as you know that for the protein, the building blocks are nothing but the amino acids. So how these amino acids come together, what is the procedure, okay, what keeps them together, all these things we are going to see in the structure of protein. So before moving on towards the actual structure of the protein, you need to know one term which is called as peptide bond. Peptide bond. Now, what is this peptide bond? See, now because these proteins, okay, means amino acids are the building blocks of protein. The amino acids, when they come together, they should be binded somehow, right? They should be kept together by some bond. So that bond is nothing but this peptide bond or peptide linkage. Means in short, it is nothing but the bond formed between two amino acids by elimination of water molecule. Okay, so it's represented like this CONH bond. CONH means nothing but the peptide bond. So it will be C OH plus H, double bond O, NH, with the elimination of H2O. There will be a formation of peptide bond. Okay, so this is called as what? Peptide bond. And with the help of the peptide bond, how many amino acids join together? Okay, that time the thing which is formed is called as what? Peptides. Okay, so depending upon how much number of amino acids get attached to that to form a particular chain. Okay, again there are different types of it. So depending upon the number of amino acid residues, there are again few types. Okay, so one is called as the peptides. Okay, the types of peptides I'm saying. So first one is dipeptide. Second is tripeptide. Third, tetrapeptide. Fourth, oligopeptide. And fifth one is polypeptide. So peptides means, you know, that is the number of amino acids which will be present in that chain. And the first two letters, that is di, tri, tetra. Di means 2, tri means 3, tetra means 4. Oligo means it can be in between any number 2 to 10. And poly means n number. Okay, so polypeptides means what? If suppose say that there are 100 amino acid residues, okay, in that particular chain, then that time that particular protein is called as what? Polypeptide. So because it's having more number of amino acid residues, it will be also having what? High molecular mass. Okay, So how these polypeptide chains are formed together? So what happens is each of these polypeptides they will have a free amino group at one end and a free carboxyl group at another end. Okay, and this ends are only called as what? End group. Okay, they are called as what? End groups. End groups means nothing but two terminals will be there. One is called as the N terminal, the second one called as the C terminal. Now what is this M and C terminal? Now see, I already told you that amino acid will be having what? Amino and carboxyl group. So obviously there will be two terminals, N and C end groups, right? So therefore, whenever an amino acid is having a free NH2 group, that is the amino group, I'll just write it down. Okay, the amino acid unit having free amino group, it will be having N terminal end. And when it is the opposite, that is when it is having free carboxyl group, then that terminal will be called as C terminal end. Okay, so I'll just show you this in the form of a structure. C double R. Okay, so one is R, R dash, and yes. Okay. So here, if you see, the first one is having what? N terminal. N terminal. And here, this side, it is C terminal. And this in the between is the polypeptide. Okay, so why this is N terminal and why this is C terminal, I hope you guys have understood. Here, if you see NH2, so N terminal at the end. Here it is COOH. So therefore, it is C terminal at the end. Okay, are you getting my point? Okay, so usually when I say structure of protein, okay, it will be having 4 groups in it. Okay, so first one is the primary, then secondary, tertiary, and quaternary structure. So these are what? The 4 structures in a protein. So first let us see the primary. Okay, now primary protein structure means what? It is nothing but a sequence in which amino acids are arranged in a protein. Okay, so primary structure means a very simple structure of the protein, simplified structure of the protein, wherein what will happen is just there is a sequence, okay, wherein the amino acids are arranged so as to form a particular chain of a protein. Okay, so depending upon what type of sequence it is, you will get what? The functionality of that particular proteins. Means in short, the sequence is going to determine function of protein. Okay, so the first primary structure is very simplified structure. Okay, Then comes the second one, which is the secondary structure. Now, what is this secondary structure? Whenever a primary structure undergoes folding or coiling, then it is called as a secondary structure of protein. Okay, so a structure formed due to folding or coiling of polypeptide chain is called as what? Or that particular structure is called as what? Secondary structure of protein. So basically what happens in this is there will be two different types or structure. Why there will be two different types of structure? Due to the folding or coiling of that particular polypeptide chain. Okay, so whatever the backbone of the polypeptide chain is there, okay, it will get either folded or it will get coiled due to a particular type of bonding which is present in them called as H bonding, hydrogen bonding. Okay, so how is the secondary structure formed, or what is the bonding involved in forming the secondary structure? It is the H bonding, that is hydrogen bonding, which takes place between the two groups of the peptide bond, which is nothing but C double bond O and NH groups. Okay, so whenever the secondary structure is undergoing a alpha helix or a beta pleated sheet, okay, it'll form that particular two structures. Okay, so I'll just, guys, please join to the next link. Okay, this one, the same link, please join back again.